All right, so this last one here, we're just going to talk about finding vertical asymptotes. Okay, so I want you to read through Sarah and determine is she correct. Explain your reasoning on what she has for finding her vertical asymptotes. Remember, that's where, when we're talking about vertical asymptotes, it's what gives me error in my calculator for the x values. Okay, so pause the video here and try to answer whether you think Sarah is correct or not. All right, so if I do this, remember when we first factor our bottom to see what x can't be, you first look for a GCF. So she looked and she said, okay, well, I can pull 2 out of the bottom. Then if she snowflaked this, that's where she got her factor form. She then said, okay, well, if I do my zero product property, I will find those x values that will give me error in my calculator. So she took x minus 8 and set it equal to 0 and x plus 1 and set it equal to 0. So when she solved them, she got a positive 8 and a negative 1. So if I actually plug those in, will they give me error in my calculator for those asymptotes? Okay, if I plug this 8 in here, 8 minus 8 is 0, which is going to give me 0 at the bottom of my calculator. If I plug the negative 1 in, negative 1 plus 1 will also give me error in my calculator and a 0 at the bottom. Okay, so those are correct vertical asymptotes for that. So what we're actually going to practice doing is factoring and doing ZPP to find what values would give me error in my calculator for those x values. Remember, x values deal with vertical asymptotes. Okay. So the first one here, we just look at the bottom. That's the only thing, because 0 in the bottom of a fraction is where it's error, 0 in the top is okay. So if I take 7x minus 35, remember your first check is there a GCF? Your second check is your front guy positive? And your third check is, can we factor? Is there still an x squared left in it that makes me have to factor? So my first check is there GCF? There is. For this one, I can take a 7 out. So I'm going to divide them both by 7. I'm going to get x minus 5 left. Anytime I see an x, I can take that set and do kind of what zero product property was, set it equal to 0. So I'm going to take x minus 5 and set it equal to 0. It's only when you see an x. If I set 7 equal to 0, it's not going to do anything. 7 will never equal 0. So really, it's only time you see an x value that you're going to do this. So if I add 5, I got my vertical asymptote to be at x equals 5. If I plug 5 back in there, I get 5 minus 5, which is 0, which would be an error in my calculator. Okay, if I were to graph this, you just have to remember, put this in parentheses. So go ahead and graph it and double check. Do your 5 divided by parentheses 7x minus 35. You should see that asymptote at 5, x equals 5, that up and down line. Okay, my next one here, it's already in factored form. Okay, factored form meaning those parentheses sets, it's in multiplication mode, so I can't really pull anything out. So anytime I see an x, I'm going to set it equal to 0. So there's 1, and there's 1. Okay, I don't even have to solve on this one. That one's good. This one I'm going to add 2. This one I have to subtract 3, divide by 2. So all of my asymptotes, I'll have an asymptote at 0, an asymptote at 2, and an asymptote at negative 1.5. So what my graph will look like, there's going to be 1 here, there's going to be 1 here, and there's going to be 1 here. So everything's going to be super close together when you look at this graph. Okay, I want you to snowflake the bottom and see what is going to give you that error in the calculator. So snowflake it and then do your ZPP properties. So pause the video and try it out. All right, negative 10, negative 3, x, negative 5, 2. So x minus 5, x plus 2. So if I solve this one, I add 5 to get 5, I subtract 2 to get negative 2. So my asymptotes will be at 5, my vertical asymptotes will be at 5 and negative 2. Okay, so what I want you to do is I want you to pause the video and I want you to try the rest of them and see what you can do here. That is the next one. I've got my A times C, my B, my front guy. So this is going to be 8 and 1. So 2x plus 1. Divide by 2 to get x and 4. 2x plus 1 is equal to 0. x plus 4 is equal to 0. So if I subtract 4, this one I would subtract 1, divide by 2. So I get negative 4 and negative 1/2. Okay, and my x to the 4th. Okay, let's pretend it says x squared minus 1. So if I actually snowflake x squared minus 1, my a times c, my b, my front guy, this would be, it multiplies the negative 1, adds to 0. Negative 1, positive 1. So he would really be x plus 1, x minus 1. Okay, but instead of x squared to x to the 4th, so all I really have to do is put squares on these, because x squared times x squared will get me x to the 4th. So I'm going to have 7 over x squared minus 1, x squared plus 1, or what we could do is just set it equal to 0 and solve it. So x to the 4th, I'm going to show you both ways to solve. So I could set the whole bottom equal to 0 and now factor it, or I can now do this. X squared minus 1 equals 0, x squared plus 1 equals 0, and solve that. So if I solve this left one here, I would add 1. To get rid of the 4th, I would have to do the 4th root. Okay, this one, I would add 1. Take the square root, and I would get a plus or minus 1. This one, I would subtract 1. We can't take the square root of the negative, so p doesn't really exist. So positive and negative 1, which if you take the 4th root of this, it will give you a positive negative 1. Okay, so a little bit trickier because we haven't really experienced x to the 4th. Right, x squared plus 2, if I try to still plug in a times c, b, x, nothing multiplies as 2 and adds to 0. So if I just try to solve it, since there's only one x, I can use square root property. I'm going to subtract 2. Try to square root, can't square root negatives. He doesn't have a vertical asymptote. Okay, which is interesting. So it's only going to have a horizontal asymptote. There is no value that when I plug it in for x, will give me an error in my calculator or a 0 in the bottom of my fraction. That's what that means. There's no value that will give me an error. Okay, my next one shouldn't be too hard. Okay, this one I would subtract 2 to get negative 2. This one I would add 5 to get positive 5. Okay, this one's actually going to create a hole. You're not actually going to see him on your graph, which is going to be interesting. So when I say a hole, it'll still say error in your table, but let's see, 4, 5. It's going to look like this. And then my other guy, so where's that, negative 2? So at negative 2, there will actually be a hole instead of an asymptote. So an open dot where you're not going to cross. Right? And the reason that is because it's the same thing on top and bottom, which you'll discover a little bit down the road. Okay, so go ahead and I already kind of talked about this and had you checking with your graphic calculators. Okay, but you can go ahead and use your graphing calculators with this. Just make sure you use parentheses for the bottom. Or you can look at your table and look at the errors for the table. The only time you're not going to see the error in the table is if it's a decimal, because your table is represented of whole numbers.